Okay, so I'm gonna be solving this problem right here. First thing I want to do is define a few things. So we're gonna talk about tension first. What is tension? Well, tension is this guy right here. And it's also this guy right here. Okay, so tension is really defined, if I'm going away from the joint, then that's tension. Okay, so let's go ahead and prove that. So if you notice, I took this guy right here and I simplified it right here. So you can see that these two are the same, this one and this one. So remember, in statics everything is equal and opposite, so equal and opposite, and same here. You can see that right here I have tension, right? This guy is pulling in this direction, and this guy is pulling in this direction. Okay, so that's the definition of tension. Now let's go ahead and do compression next. Now, this is tension, right? So compression is this guy, and I'll show you why. So that's here. In statics, everything is equal and opposite. Okay, so you can see that this guy right here is in compression. This guy is pushing in, and this guy is also pushing inward. Okay, so now you know what tension and compression are. So let's go ahead and draw our arrow back out this way. Now, next thing you need to know is, what is a force triangle? Well, let's take this guy right here, and let's look at him a little bit deeper, right? So, if you notice, the way a vector works is, I start here, right? And then I'm going to go from the tail of the vector to the head of the vector here. So you'd go like this. You would go this direction, right? And then you would go up in this direction. Okay, so that's how it works. This and this are the same. So I took this vector and I slid it over here. Okay, so that's what this is. These two are the same. Okay, so now we have the basic definition of the force triangle. So don't forget your trig right here, SOHCAHTOA, right? This is pretty important. So let's go ahead and solve for this guy. So this would be... Okay, when I solve for this, what do I get? I get this. We've solved for the x component here. Now if I can do the same for the y component, right? I can do the same for this guy. Okay, and if I solve for this, I'll get pretty much the same thing, right? I'll get this. Okay, so now we have this guy and this guy. Okay, so let's go ahead and get into the problem now. Okay, if you look here, I went ahead and drew all my forces out. So one thing I want to point out is we went ahead and we're assuming tension here, right? So we're gonna assume these directions here. Now, we don't really know that this is going in this direction. For all we know, this could be going in this direction. But for now, we're gonna assume tension. So if you look here, I have 1, 2, 3, 4 forces. So what is P2? Well, P2 is right here. We know this value. So let's go ahead and use what we have. So we know that, let's do summation of forces in the y. So we know that P2 is pushing down right here, and then pushing up is this guy, CB and the y. That's right here. So if you notice, CB and the y is equal to this. So go ahead and put that into your equation here. Whenever we solve for CB, we end up getting this guy. So if you notice, we got a positive value here. So what does that mean? That means that we selected the right direction. So this member is in tension, for sure. Okay? So we selected the right direction there. So we're going to go ahead and put a tension here, and then we solved it here. Okay, so let's go ahead and continue with our force triangle, right? Remember, this is our force triangle right here. So if we look here, we notice that we're going to do summation of forces in the x direction now. So let's go ahead and do that right here. Now, I'm going to go ahead and say that... Okay, next thing I want to do is summation of forces in the x. Now, I have my coordinate system here, okay? So I know that CD is pushing the negative direction here, right? In the negative x. So I'm going to put a negative CD in here. Okay, now we also have this guy, CB in the x, right? This guy is pushing this direction. So remember what CB in the x is, it's right here. So go ahead and put this into the equation here. So we have two vectors pushing left here. We have this guy pushing left and we have this guy pushing left. Now we solved CB earlier, so we know it's a positive number. So what happens here? Well, if I take this equation, when I solve for CB, I get a negative answer. Okay, so what does that mean? That means that we selected the wrong direction here, right? So selecting this direction gives me a negative answer. So go ahead and fix that. So we're going to go ahead and draw this vector this way. Right? Whenever we do this, we get a positive answer here. And you can see that this is in compression, right? And remember, if you look at your joint here and your vector is going out this direction, this would be tension. Okay? But if you look at this point and you go inward, like this would be compression. Okay, so you can see that CB here is in tension, and CD is in compression. So we have this. And we've also solved for CB, which is this guy. Okay, so next, we're going to move on to this joint right here. Okay, so the first thing I did is I went and cut the beam. I cut it here, here, and here. Okay, and that's exactly what this is down here. Next thing I did is I went ahead and drew everything in tension, right? So I have my coordinates set up right here for my positive directions. This is from earlier, so we know this guy and we know this guy. This is just a reminder. Now let's go ahead and do summation of forces here. Now DC is pushing in this direction, right? So that's positive. So we went ahead and put a positive here. And DE right here is pushing in the negative direction. For DE, we're going to get this answer right here. So if you notice here, DE is actually, we chose the right direction because we got a positive answer. So that's pretty helpful. Okay, now let's go ahead and do summation of forces in the Y. Let's go ahead and do this guy. So we know that this guy's pushing down, right? So this one must be pushing up, right? This would be equal and opposite to this one. Okay, so go ahead and put in P1, pushing down, and then DB is pushing up. Okay, when you solve for DB, you get this. So we picked the right direction here. So we know that this is for sure in tension. Okay, so we have one last step. We need to find this guy, right? So we need to find BA here, right? We gotta find this guy. So I have all of these, right? And I went ahead and put that down here. Now I went ahead and assumed tension for this guy. So let's go ahead and get into it. So BC is what? BC is this. BD is this guy. BE is this one. Okay, and we're gonna solve for this. First thing we're gonna do is we're gonna look at this and we're gonna go summation of forces in the x direction. First thing I do is BC cosine theta. So that's this component right here. Okay, you can see that this is pushing in the positive x direction here. Next thing I did was BE cosine theta. That is right here. Now, I'm going to subtract that by BA cosine theta, which is this guy. Whenever I solve for BA, I get a positive number. So that tells me that I selected the right direction here. So BA for sure is in tension. In the end, we get this. Solve for every member here. Oh, we're done.